Okay, I am going to want you guys to try this section on your own. I will kind of go through real quick and give you little pointers about how you can kind of start thinking about those problems. Because again, it's like what we just did on the last section with Ka and stuff. It's like sometimes it gave us a pH and we had to work backwards to get the H plus concentration. And then we know that this equation is always going to equal the x squared minus the HA minus x. And then we could solve for the H plus concentration, right? And then get a Ka and then a pKa or vice versa, right? Or if it gave us the Ka, we could then do an ice table solve for x. X equals the H plus concentration. We were able to come up and plug it right in up here. So at the bases, it's going to be kind of the same kind of idea. So it's like we're going to use this equilibrium expression here. And what matters in the Kb one, just like with the Ka, what mattered was our H plus. What matters in the Kb is going to be the hydroxide concentration, because we're going to need the hydroxide concentration because we can use that to then get the pOH. And once we have pOH, we can then come up and get the pH by doing this way. So it's like we're thinking of it the same way. And like that OH minus concentration, that hydroxide concentration will always be equal to X when you do an ice table, right? And then we're always going to be able to do the same way that we just did it with the Ka, but now, right, we technically get a pOH, but then we just use this equation up here to then get the pH. So it's just kind of like what we did in the last couple videos, but now you're just kind of adding the extra step, perhaps, when you have to now think of like you have a base, so you're dealing with hydroxide, you're not dealing with free H plus floating around. And then, right, we're getting a pOH that we can then use to get a pH. And then once you have a pH, you can then find out how much H plus is really floating around if you needed to, so on and so forth, okay? So just kind of look at the numbers, and just to give you kind of some pointers for you guys to try these on your own. Okay. So number 39, a cup of coffee has hydroxide ion concentration of blah, blah, blah. What's the pH? So it's giving you, I was kind of writing little notes here. It's giving you an OH concentration here. Right? So you're going to use your formula sheet. You have your OH. I really suck at writing brackets. Okay. It wants you to find the pH in this problem. So it gives you the OH minus concentration. Use this equation here, 10 to the minus, sorry, what am I doing? Which one was it? What's it asking for? pH of the coffee. So to get the pH, you need to get the pOH. So you're going to do the negative log of that hydroxide concentration. That will give you the pOH. Then you're going to plug it into this equation here. So you're going to do the pOH equals negative log of this, which you already have. And then once you have that, you're going to use the pH plus pOH equals 14 to solve for your pH. Be careful for your sig figs. You have 2 that you have in this problem. So technically, this answer should give us 2 sig figs after the decimal, right? You guys wouldn't have made that mistake though. Number 40, what is the concentration of hydroxide in a 0.2 molar solution of ammonia? The Kb value is blah, 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 blah. Well, this is one where, right, you're going to do the Kb, and we already know what that formula is, right? It's like the products over reactants. We've done this a million times. Here it is right here. We can do an ice table if we want to, but it's going to be, we're going to end up with the same thing, guys. X squared minus m minus x, right? Check the rule of 100 first. Solve for x. Once you get x, your x is going to be equal to your OH minus concentration. Just like with an acid, x was our H plus concentration. When we are dealing with the Kb, right, we could have done a big ice table, but this would have been x, this would have been x, and this would be this minus x down here, right? And we did the ice table because we had to get those numbers at equilibrium, right? Same kind of thing that we just did, but now our x is our hydroxide concentration. We're dealing with a base now. Bases don't release H+. That's only for the acids. So solve for x. X is going to give you the OH minus concentration, which is exactly what this problem is asking for. Keep in mind you get 2 sig figs because this is 2. Number 41. What is the pOH of a 0.2 molar solution of ammonia? The Kb value is blah, 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 blah. Well, if it gives you the Kb, right, and we know this is true, check the rule of 100 to see if you can eliminate this, which you could have done up here, 2. You're going to solve for X, but X is going to be your OH minus concentration. Well, if you have your OH minus concentration, you sure know how to solve for pOH, right? It's right in your equation sheet. Plug that guy right in there. And that's what the problem is asking for, is just the pOH. 42 is asking for the pH of that same solution up here. So we can just do everything we just did. But look, it's the same exact solution, same concentration, same Kb value. So once you have the pOH from up here, you're going to use the pH plus the pOH, which will be your answer from this problem up here, equals 14. Solve for pH, you would get the same number of sig figs that we had, which should be 2. And it looks like the answer choices do have 2 sig figs in the decimal portion, which is what matters, right? For pH and pOH, it's only after the decimal that counts. Same thing with pKa and pKb. 43. What is the hydronium ion concentration of this solution, blah, blah, blah. Well, this is the same exact problem, guys. Look, it's same concentration as this up here, same Kb value. So in number 42, you actually solve for the pH. So once you have the pH, this one's asking you for the hydronium concentration, which is H3O+, which is the same thing as the H+ concentration. And if you have the pH, how do you find the H+ concentration? Well, your H+ concentration, according to your formula sheet, which you can look up, our H+ concentration is going to be 10 to the minus pH. Again, I'm not pulling it out of nowhere. I'm getting that directly from here, right? Then you're going to be able to use that to get your H+ concentration. 44, what is the pH of a 0.500 molar solution of trimethylamine? Okay, it gives you the pKb. So what did we do last time that happened to us with the pKa? If we get the pKb, what you're going to need to get is you're going to have to solve for the Kb. I should probably draw an arrow. How are you going to get the Kb from a pKb? Oh, look, your formula's on here. You're going to do 10 to the minus pKb. So once you're going to take the get the Kb. Once you have the Kb, right, you could do a whole ice table thing, and then you could solve for X, right? But once you have X, you have to remember that X is your hydroxide concentration when you're doing a base. So if you do that, your X is going to be your hydroxide concentration. So once you get your hydroxide concentration, you can go from, right, so I'm going from my hydroxide concentration, then I can get my pOH. And once I have my pOH, I can get my pH, because pOH plus pH is always equal to 14. 44 is a good problem. Okay. Actually, maybe let's stop there, because like 45, I think, and beyond is like a big mix of weak bases, their conjugates, just other kind of practice with like all the other kind of problems that we just kind of did. So I think so far the most difficult one might be this number 44 here. How you have to kind of walk through this whole thing. pKb to Kb to X, which is your OH minus, pOH, pH. Right? Just remember, bases, we're only dealing with hydroxide and pOH and all that kind of stuff, right? We have to use that information to get the pH. The rest of this might be kind of good practice. If I remember right from last year, there might be like 1 or 2 on here that might have been too hard. But I don't remember. I'll have to look at it a little bit later. But so far it's enough. You can do this one and then kind of good review, kind of going through the rest of this. But this is great practice for, right, getting familiar with all this stuff. We just learned a lot of stuff in class. Right, we kind of covered all this just like super fast and what all these were and blah, 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 how to do a nice table. But this was, like I told you guys, great practice of like how it all ties together. And you guys are going to get really good at being able to like, right, if you're asked to make a base, knowing like, well, if I have a base, like what information can I get from this? And then can I calculate a Ka? Can I get an OH minus concentration to then get a pH? Blah, 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 blah. Like this is great practice to be able to manipulate all the formulas. Because you'll have to be able to manipulate all them when you do your lab test, right? Depending on what you're assigned, like you have to be able to like take what you're given and manipulate everything to get other variables and other things that you actually need in the lab. So watch these videos again and again if you don't get it. If you want to come in for help with this, I do ask that you've at least like watched the video like on the one that you're stuck on, that particular problem you're stuck on, like watch it a couple times. So like when you come in, you're like specific with questions. Like, I don't understand how you did this or why you did this part. Come with specifics, not like, hey, start at the beginning and tell me how to do it. Because that's why I'm sitting here making these videos. It's almost 10 o'clock at night now, but I'm doing this so that right? Like anybody like that's having trouble coming after school, right? Because they have soccer practice or track practice or games or anything like that, right? It's all kind of right here. Try to help you kind of like so it kind of seems like a one-on-one, and then come in with specific questions and or email me with specific questions. But maybe later I'll do a video on some of these review things, but I do encourage you guys to try the rest of those on your own. And then we'll start on neutralization reactions in class. And that'll be kind of like, we're going to take all this and apply it to neutralization reactions in the titration lab that we're doing.